Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid Ibrahim Sokaha and my number metric is DE210095. So today we are from group EG3. We'll present our integrated design project which is wind turbine with power regulator with our supervisor Dr. Jabat Al-Fatah bin Jahaya. This is our group members which is Muhammad Ikmal bin Cik Masarwi, Irsyad Syambi bin Hussein, Muhammad Arif Hazim bin Nur Tajuddin and also me Muhammad Farid Ibrahim Sokaha. For the introduction, renewable energy, including wind energy, is crucial for combating climate change and reducing fossil fuel reliance. With 29% of the world power produced in 2021, this percentage is expected to rise as more cost-effective and efficient sources become available. Wind turbines suitable for residential and downtown areas are expected to gain popularity in the future. For the problem statement, wind turbines are promising technology for electricity generation, but they face issues such as intermittent generation due to changing wind speed, which can lead to reliability problems and challenge in grid integration. This complex machine can also be damaged by extreme weather events such as hurricanes and tornadoes, causing catastrophic failure. Additionally, noise produced by wind turbines can cause disturbance to surrounding area, especially in onshore area near residential areas.
Assalamualaikum warahmatullahi wabarakatuh. My name is Irsyad Syami bin Husaini. My metric number is DE210109. For objective, the first one is to maximize power output at a given wind speed, and then to be strong enough to endure severe weather and long operation hour. The third one is to minimize noise pollution, and the last one is to reduce greenhouse gas emission and other pollutants from fossil fuel power plants. Next part is scope of work. The first one is component selection, identifying the ideal materials and components that the turbine will be constructed with. Second one is system design, where designing the turbine structural element such as the motor, wiring, blades, and sensor. And then installation, install the turbine in an area that generates enough wind power. And the last one is operation and maintenance. Perform monitoring and frequent maintenance are required to maintain the turbine working safely and effectively. Next, we move to the proposed solution. The first one is use material that is ideal, which should be stronger and lighter to increase the blade's durability and efficiency. Second one is applying a sensor that can function at various speed based on the wind speed that can help to maximize generated power regardless of the speed of the wind. And then the last one is installing it vertically so the airflow to flow over the blade more slowly and produce less noise since the blade is flowing parallel to the direction of wind. Okay, these are the components that we use in this project, where we use Arduino Uno, inductor, capacitor, diode, MOSFET, motor driver, LED light, and wind turbine generator.
Is Muhammad Ikmal bin Chamat Salvi. My number matrix is DE210098. So next, we will discuss about the circuit of the wind turbine of this project. So the circuit of the wind turbine of this project will containing Arduino Uno as our microcontroller, L298N motor driver board as the driver for the MOSFET of the booster circuit. The motor wind turbine maximum voltage is 5 volt. Booster circuit that contain a inductor, MOSFET, diode, capacitor, and our load is a LED light. Maximum voltage is 5 volt. So the reason why we use a booster circuit for this project is because motor wind turbine will not give a permanent voltage, which is it will give a voltage about 1.5 volt to 5 volt. So if it give a average of 3 volt voltage, the LED light will not continuously bright. The brightness of the LED light will not continuously to be ignite. So booster circuit will regulate the brightness of the LED light by increasing the duty cycle in the booster circuit, and the brightness of the LED light also will be up. So for this project, the test will be test on the lab by using the external voltage of the DC voltage in order to give a permanent voltage to 1.5 volt to 2 volt, 3 volt, 4 volt, and also the 5 volt. So the test will be conducted by using external supply, because by using the wind turbine, it will be harder for us to achieve our desired voltage value. So the start will be 1.5 volt for the test of the circuit booster. So up duty cycle to 10%,
10%,
20%, 30%, 40%, 60%, 70%, 80%,
90%,
up to 2 volt. So the duty cycle to up to 10%,
10%,
20%,
20%,
30%,
30%,
40%,
40%,
50%,
50%,
60%,
60%,
70%.
70%,
Test is a 3 volt. So duty cycle up to 10%,
10%,
20%,
20%,
30%,
30%,
40%,
40%,
50%,
50%,
60%. Same. Is already light up the light, but we can set up to 10% test of duty cycle first.
10%,
10%, nothing changed.
20%,
20% is nothing changed.
30%,
30% has a little bit change. Up to 40%.
40%,
40% is a little bit. Up to 50%,
50%.
nothing changed. It's a 5 volt. 5 volt doesn't even need a duty cycle because it already light up the LED light.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Fazli bin Tajuddin. I'm a matrix DE210043. And today I will discuss about the result test from the demonstration video. So as you can see here, we test the system with 4 different voltage, which are 1.5 volt, 2 volt, 3 volt, and 4 volt. Alright, when we inject to 1.5 volt, when we turn on, when we put 10% of duty cycle, it was extremely dim. Then we increase it step by step until it was 90%. Then we will get the extremely bright result from the lamp. Next, for 2 volt, when we it put the 10% of duty cycle, it was dim. Then when we increase it step by step until 70%, it was extremely bright. The same goes to 3 volt, where we put 10% of duty cycle, it was dim. Then the maximum brightness that we can get is 50% duty cycles. Also goes to 4 volt. When we put a 10% duty cycle, it already bright. But to get the extremely bright, we need to increase it until 30% of duty cycle. For 5 volt, there are no changes when we increase the duty cycle because it already have extremely brightness. Alright, that's all for me. Thank you.